Question 1. Histograms and standard deviation. So showing the estimate for the mean weight, well, the first thing we need to know is what are the frequencies, and then we'll be using the midpoints, just like you would do with a group frequency table. So that's going to give us something looking like this. So the class width is going to be 2 every time. The midpoint for the first one is going to be 61. For the second bar is 63. The third bar is 65. And the last bar is 67. The frequency densities are 3, 12, 8, and 2. So if we're 2 times 3 is going to give you a frequency of 6, 2 12s, 24, 2 8s are 16, and 2 2s are 4. And then what they're really going to be looking for you to do is to multiply the frequencies by the midpoints and then divide by how many we've got. So if you add up the frequencies, that should give you 50 plums there. And so using your calculator, you're going to be doing 6 times 61 plus 24 times 63 plus 16 times 65 and then 4 times 67. And if you put all of that into your calculator, you should get exactly 3,186, and we'd be saying, oh, it's going to be nearly equal to the mean. 3,186 over 50, and that does come out at being exactly 63.72 grams. And then when it comes to finding the standard deviation of the 50 plums, you're looking into your formula book, and here we go here. Now you can get the information straight off your calculator if you've sort of pumped that all in there, but the best way to sort of show it through is to show you summing up the squares of your numbers, dividing it by n, and then taking away x bar squared. So that's going to look something like this. You've got your midpoint, you've got your midpoint squared, and then you've got your frequency times your midpoint squared. And you've got your frequencies, so your 4 frequencies are 6, 24, 16, and 4, 61, 63, 65, 67. And remembering what we're trying to do here is the sum of the data squared divided by 50, all taken away by the mean squared. So if you've got your midpoint squared, so 61 squared is 3,721, 63 squared gives you 3,969, 65 squared 4,225, 4,489, and then you just need to multiply these by the frequency, so 6 times 3,721 and so on, which should give you these values here, and if you add those together, that should give you 203,138. And then what you're going to be putting into your calculator is going to be that 203,138 divided by the number of data pieces, which is 50. Take away your mean, which we already know is 63.72 squared, and that's going to come to 1.587 something. We always leave things to 3 significant figures, so then we're going to be saying it's going to be about 1.59 grams is the standard deviation from the mean. And then we've just got the last part. State the effect this if each plum actually weighs 5 grams less than originally thought, state the effect this will have on the estimate for the standard deviation. Well, if every plum is reduced by 5 grams, The mean's going to go down by 5 grams, but the standard deviation won't change because it's a measure of spread, and there'll be no the spread will be the same for all of your plums there. So you just need to say no effect and something about as standard deviation is a measure of spread. Okay.